Picture this, a world drifting silently through the endless void of space, untethered to any star, no sunrise or sunset to mark the passage of time. A world that belongs to no one and yet holds secrets that could rewrite everything we know about the universe. These are rogue planets, lonely wanderers of the cosmos, free from the gravitational pull of any star, moving through the darkness like cosmic nomads. What if I told you that these mysterious worlds might outnumber the stars in our galaxy, that they could be hiding oceans beneath their icy surfaces, or even clues to life itself? Tonight, as you settle in, let your mind wander with us into the vast, uncharted reaches of space, where rogue planets drift in silence, carrying stories older than time. Where are you joining us from, and what time is it there? Let us know in the comments below. Now, close your eyes, take a deep breath, and let the mystery of these wandering worlds guide you into a peaceful, cosmic slumber. Now turning to the heart of the mystery, let's explore what rogue planets truly are. Imagine a celestial body, much like Earth or Jupiter, but with one striking difference: it doesn't orbit a star. These are rogue planets, worlds that wander freely through the vast expanse of space, untethered by the gravitational pull of any sun. They drift in the darkness, solitary and silent, like cosmic nomads on an endless journey. But how do these wandering worlds come to be? Some rogue planets are born from chaos, violently ejected from their star systems during the turbulent early days of planetary formation. Picture a young solar system, planets jostling for position, and one unlucky world flung out into the void, never to return. Others, however, may form on their own, emerging from dense clouds of gas and dust in the cold, dark regions of interstellar space. These planets are born without a star, destined to wander from the very beginning. Imagine the surface of a rogue planet. No sunlight to warm it, no day or night to mark the passage of time. It's a world of eternal twilight, where the only light comes from distant stars, faint and cold. Some rogue planets might be icy wastelands, their surfaces frozen solid by the relentless chill of space. Others could be rocky, barren landscapes, shaped by eons of solitude. And then there are those that might hide secrets beneath their surfaces, vast oceans of liquid water, kept warm by the planet's internal heat, a glimmer of hope for life in the most unexpected places. These lonely wanderers are more than just celestial oddities. They are a testament to the unpredictability and wonder of the universe. As we continue our journey, we'll uncover how astronomers first discovered these elusive worlds and the challenges they faced in spotting these dark, starless travelers. But for now, let the image of these drifting planets linger in your mind, a reminder of the endless mysteries waiting to be uncovered in the cosmos. Now turning to the story of their discovery, let's delve into how astronomers first detected these enigmatic rogue planets. Spotting a world that doesn't orbit a star is no easy task. Unlike planets that reflect the light of their suns, rogue planets drift in darkness, invisible to traditional telescopes. So how did scientists manage to find these elusive wanderers? The answer lies in two remarkable techniques: gravitational microlensing and infrared observations. Gravitational microlensing is a phenomenon that occurs when a massive object, like a rogue planet, passes in front of a distant star. The planet's gravity bends and magnifies the star's light, creating a temporary brightening that astronomers can detect. It's like a cosmic magnifying glass, revealing the presence of a hidden world. This method has allowed scientists to identify rogue planets that would otherwise remain invisible, offering a glimpse into their mysterious existence. Infrared observations, on the other hand, rely on detecting the faint heat emitted by these planets. Even though rogue planets are far from any star, some retain internal heat from their formation or radioactive decay. Using powerful infrared telescopes, astronomers can pick up this subtle warmth, painting a picture of these cold, dark worlds. It's a bit like finding a faint ember in a vast, dark room, challenging, but not impossible. The first confirmed discovery of a rogue planet came in the early 2000s, sparking excitement and curiosity in the scientific community. Since then, dozens more have been detected, each one adding to the mystery and allure of these wandering worlds. The discovery process is slow and painstaking, requiring patience and precision, but every new find brings us closer to understanding these cosmic nomads. Imagine the thrill of spotting a planet that defies all expectations, a world without a star, drifting alone through the galaxy. Each discovery is a reminder of how much we still have to learn about the universe. As we continue our journey, we'll explore the loneliness of these rogue planets and the emotional resonance they hold, not just for scientists, but for all of us who gaze at the stars and wonder what lies beyond. Now turning to the loneliness of rogue planets, let's explore the emotional and poetic side of these wandering worlds. Picture a planet, untethered from any star, drifting endlessly through the cold, dark void of space. It's a journey without a destination, a story without a beginning or end. These rogue planets are the ultimate cosmic nomads, forever moving through the vast emptiness, far from the warmth and light of a sun. Imagine being on such a planet where the sky is perpetually black and the only light comes from the faint glow of distant stars. There are no sunrises or sunsets, no seasons to mark the passage of time. It's a world of eternal night where the silence is as deep as the darkness. This is the reality of a rogue planet, a place of profound isolation where the only companion is the endless expanse of space. Yet, there's a strange beauty in this loneliness. These planets are like cosmic wanderers, carrying the echoes of their origins as they travel through the galaxy. They remind us of the vastness of the universe and the countless mysteries it holds. In their solitude, they evoke a sense of wonder and melancholy, a reminder of how small we are in the grand scheme of things. Think of them as celestial drifters, moving through the cosmos like ships without a harbor. They are free, unbound by the gravity of a star, yet forever alone. Their journeys are a testament to the resilience of existence, a reminder that even in the coldest, darkest corners of the universe, life, or the potential for life, can persist. As we reflect on these lonely worlds, we can't help but feel a connection to them. They are a mirror of our own search for meaning and belonging in an infinite universe. And as we continue to explore the mysteries of rogue planets, we'll uncover not just the science behind their existence, but also the profound emotions they inspire in all of us who look to the stars and dream. Now turning to the possibility of life on rogue planets, let's explore how these wandering worlds might hold secrets that challenge our understanding of where life can exist. While rogue planets drift far from the warmth of any star, some of them could still harbor environments where life might thrive. Imagine a planet cloaked in eternal darkness, with no sunlight to warm its surface. Yet, beneath its icy crust, there could be vast oceans of liquid water, kept warm by the planet's own internal heat. This heat, generated by radioactive elements deep within the planet's core, could create a stable environment where life might find a way to survive. These subsurface oceans could be hidden beneath layers of ice, shielded from the freezing temperatures of space. In such an environment, life might rely on chemical energy rather than sunlight, much like the organisms found near hydrothermal vents in Earth's deep oceans. These vents, teeming with life, show us that even in the most extreme conditions, nature finds a way. Could rogue planets host similar ecosystems, thriving in the darkness and cold? It's a tantalizing possibility that sparks the imagination and challenges us to rethink what we know about life in the universe. Of course, the challenges are immense. Without a star to provide energy, any life on a rogue planet would need to adapt to a world of perpetual night and limited resources. The pressure of the icy crust above, the lack of sunlight, and the isolation from other celestial bodies would make survival a constant struggle. Yet, life on Earth has shown us that it can flourish in the most unexpected places, from scorching deserts to the crushing depths of the ocean. If life can exist here, why not on a rogue planet? As we ponder these questions, we're reminded of the resilience and adaptability of life. Rogue planets, with their hidden oceans and internal heat, offer a glimpse into the potential for life in the most unlikely corners of the cosmos. They challenge us to expand our horizons and consider the infinite possibilities that lie beyond our own solar system. And as we continue to explore these mysterious worlds, we may one day uncover the answers to one of the greatest questions of all: are we alone in the universe? With the next phase of the journey in sight, we'll now turn our attention to the incredible diversity of rogue planets, from their sizes to their compositions, and how this variety adds to their enduring mystery. Now turning to the incredible diversity of rogue planets, let's explore the vast range of sizes and compositions that make these wandering worlds so fascinating. Rogue planets come in all shapes and sizes, from small, rocky bodies similar to Earth to massive gas giants that dwarf even Jupiter. Some are compact and dense, while others are sprawling and gaseous, each with its own unique characteristics that add to their enigmatic nature. Imagine a rogue planet the size of Earth, drifting silently through the void. Its surface might be rocky and barren, with no atmosphere to speak of, or it could be covered in thick layers of ice, hiding secrets beneath its frozen exterior. On the other end of the spectrum, picture a rogue gas giant, many times larger than Jupiter, with swirling clouds of hydrogen and helium. These colossal worlds, untethered from any star, roam the galaxy like cosmic nomads, their immense size making them easier to detect despite their lack of light. But size is just one aspect of their diversity. Rogue planets also vary greatly in composition. Some are made primarily of rock and metal, resembling the terrestrial planets in our own solar system. Others are icy worlds, with surfaces that glisten faintly in the starlight, their interiors possibly hiding vast oceans of liquid water. And then there are the gas giants, with their thick atmospheres and turbulent storms, drifting endlessly through the darkness. This incredible variety adds to the mystery of rogue planets. Each one is a unique world, shaped by its own history and environment. Some may have formed in the chaos of a young star system, only to be flung into the void by gravitational interactions. Others might have coalesced from clouds of gas and dust in the cold, dark regions of interstellar space, never knowing the warmth of a star. Their diversity challenges our understanding of planetary formation and evolution, reminding us that the universe is far more complex and varied than we can imagine. As we continue to study these enigmatic worlds, we uncover more questions than answers. What processes shape their surfaces? What secrets lie hidden beneath their icy crusts or swirling atmospheres? And how do they survive in the harsh conditions of interstellar space? The size and diversity of rogue planets not only deepen their mystery, but also inspire us to keep exploring, to keep searching for the truths that lie hidden in the vast expanse of the cosmos. With the next phase of the journey in sight, we'll now turn our attention to the connection between rogue planets and dark matter, and how these wandering worlds might help us unravel one of the greatest mysteries of the universe. Now turning to the intriguing connection between rogue planets and dark matter, let's explore how these wandering worlds might hold the key to understanding one of the universe's greatest mysteries. Dark matter, an invisible substance that makes up a significant portion of the cosmos, has puzzled scientists for decades. It doesn't emit, absorb, or reflect light, making it nearly impossible to detect directly. Yet, its presence is felt through its gravitational effects on galaxies and other cosmic structures. Rogue planets, with their solitary journeys through the galaxy, might offer a unique window into the nature of dark matter. As these planets drift through space, their paths could be subtly influenced by the gravitational pull of dark matter. By studying the movement of rogue planets, scientists might be able to map the distribution of dark matter in the universe, revealing its hidden structure and behavior. Imagine a rogue planet passing through a region rich in dark matter. The planet's trajectory could bend slightly, a tiny but measurable effect caused by the unseen force. By tracking these subtle changes, astronomers could gather clues about the density and distribution of dark matter in different parts of the galaxy. This information could help us better understand how dark matter shapes the universe on a grand scale, from the formation of galaxies to the large-scale structure of the cosmos. But the connection between rogue planets and dark matter goes even deeper. Some theories suggest that rogue planets themselves might be influenced by dark matter in their formation. In the cold, dark regions of interstellar space, where rogue planets are thought to originate, dark matter could play a role in gathering the gas and dust needed to create these worlds. This interaction could provide insights into how both rogue planets and dark matter contribute to the cosmic dance of creation and evolution. As we continue to study rogue planets, we may uncover new ways to probe the mysteries of dark matter. These wandering worlds, once seen as lonely and isolated, could become valuable tools in our quest to understand the invisible forces that shape the universe. Their connection to dark matter reminds us that even the most enigmatic objects in the cosmos are part of a larger, interconnected story, one that we are only beginning to unravel. With the next phase of the journey in sight, we'll now turn our attention to the incredible speeds at which rogue planets travel through space and how their velocity shapes their journey across the galaxy. Now turning to the incredible speeds of rogue planets, let's explore how these wandering worlds race through the cosmos, often outpacing planets that are tethered to stars. Unlike planets in stable orbits, rogue planets are free from the gravitational pull of a parent star, allowing them to move at astonishing velocities. Some of these planets can travel at speeds of several 100,000 kilometers per hour, making them some of the fastest objects in the galaxy. The forces that propel rogue planets are as fascinating as their speeds. Many of these planets gain their incredible velocity during their ejection from their original star systems. Imagine a young planetary system in chaos, with planets jostling for position. In some cases, the gravitational interactions between planets can fling one of them out of the system entirely, sending it hurtling into interstellar space at breakneck speeds. This process, known as gravitational slingshotting, can accelerate a rogue planet to velocities far beyond what it would achieve in a stable orbit. But the journey of a rogue planet doesn't end with its ejection. As it travels through the galaxy, it may encounter other gravitational influences, such as passing stars or dense clouds of gas and dust. These interactions can further alter its speed and trajectory, sometimes slowing it down or even redirecting its path entirely. In rare cases, a rogue planet might even be captured by another star system, though this is a cosmic rarity. The high speeds of rogue planets have profound implications for their journey across the galaxy. Moving at such velocities, these planets can traverse vast distances in relatively short cosmic timescales. A rogue planet, traveling at several 100,000 kilometers per hour, could cross the entire Milky Way in just a few 100 million years, a blink of an eye in the life of the universe. This rapid movement means that rogue planets can visit many different regions of the galaxy, encountering a variety of environments and cosmic phenomena along the way. As we consider the speed of rogue planets, we're reminded of the dynamic and ever-changing nature of the cosmos. These fast-moving worlds are not just passive drifters, but active participants in the grand dance of the galaxy, their journeys shaped by the forces of gravity and chance. With the next phase of our exploration in sight, we'll now turn our attention to how rogue planets might influence the formation of new stars and planetary systems, adding another layer of intrigue to their mysterious existence. Now turning to the role of rogue planets in star formation, let's explore how these wandering worlds might influence the birth of new stars and planetary systems. While rogue planets are often seen as solitary travelers, their presence in the galaxy can have a profound impact on the cosmic processes that shape the universe. As rogue planets drift through interstellar space, they occasionally pass through dense clouds of gas and dust, the very nurseries where stars are born. These clouds, known as molecular clouds, are the birthplaces of stars, and the gravitational influence of a rogue planet passing through can trigger a chain reaction. The planet's gravity can compress the gas and dust, creating pockets of higher density. Over time, these dense regions may collapse under their own gravity, igniting the formation of new stars. In this way, rogue planets can act as cosmic catalysts, setting the stage for the birth of stellar systems. But the influence of rogue planets doesn't stop there. Once a new star begins to form, the surrounding disk of gas and dust can coalesce into planets, moons, and other celestial bodies. A rogue planet passing through this young system can disrupt the delicate balance of the protoplanetary disk. Its gravitational pull might scatter material, alter the orbits of forming planets, or even eject some of them into interstellar space. This chaotic interaction can shape the architecture of the emerging planetary system, determining the number, size, and arrangement of its planets. In some cases, rogue planets might even become part of a new star system. If a rogue planet passes close enough to a young star, it could be captured by the star's gravity, becoming a permanent member of the system. This process is rare, but it adds an intriguing possibility to the story of rogue planets. They might not always be wanderers. Some could find a new home, orbiting a star, and contributing to the diversity of planetary systems in the galaxy. The role of rogue planets in star formation highlights their dual nature as both disruptors and creators. They are agents of chaos, capable of scattering material and reshaping young systems, but they are also potential builders, triggering the birth of stars and even joining new families of planets. This interplay of creation and destruction adds a layer of complexity to their existence, reminding us that the cosmos is a dynamic and ever-changing place. As we reflect on the influence of rogue planets in star formation, we're drawn to the next chapter of their story, how these enigmatic worlds might interact with the extreme temperatures of space, shaping their environments and potential for life. Now turning to the temperature of rogue planets, let's explore the extremes these wandering worlds endure as they drift through the vastness of space. Unlike planets bound to stars, rogue planets lack the warmth of a nearby sun, leaving them exposed to the frigid cold of interstellar space. In the absence of starlight, temperatures on many rogue planets can plummet to hundreds of degrees below freezing, creating environments so cold that even gases like nitrogen and oxygen would freeze solid. Imagine a world where the air itself turns to ice and the surface is shrouded in perpetual darkness, a frozen wasteland stretching endlessly into the void. Yet, not all rogue planets are condemned to such icy fates. Some of these worlds harbor surprising warmth, thanks to internal heat sources that defy the cold of space. Deep within their cores, radioactive elements like uranium and thorium decay, releasing energy that warms the planet from within. This internal heat can create pockets of warmth, especially in planets with thick atmospheres that trap the heat close to the surface. Picture a rogue planet with a subsurface ocean, kept liquid by the planet's internal warmth, hidden beneath a thick layer of ice. In such a place, the contrast between the freezing surface and the warm depths below would be stark, a world of extremes existing side by side. The temperature of a rogue planet also depends on its size and composition. Larger rogue planets, especially gas giants, can retain heat more effectively than smaller, rocky worlds. These massive planets might have swirling atmospheres of hydrogen and helium, with storms raging across their surfaces, driven by the heat escaping from their interiors. Smaller rogue planets, on the other hand, might cool more quickly, their surfaces becoming frozen and lifeless over time. Yet even these smaller worlds can surprise us, with geothermal activity or tidal forces from nearby moons, creating localized warmth. The extreme temperatures of rogue planets remind us of the incredible diversity of these wandering worlds. From frozen deserts to warm, hidden oceans, they challenge our understanding of what a planet can be. As we ponder the contrasts of heat and cold on these distant worlds, we're drawn to the next chapter of their story, how time itself might behave differently on rogue planets, where the absence of a star creates a unique rhythm of existence. Now turning to the concept of time on rogue planets, let's consider how these wandering worlds experience the passage of days, years, and even millennia. Without a star to rise and set, rogue planets exist in a state of eternal night, where the concept of a day becomes meaningless. There are no sunrises to mark the morning, no sunsets to signal the end of the day, just an endless expanse of darkness stretching across the horizon. Time, as we know it, loses its familiar rhythm, replaced by a timeless void where the only measure of change might come from the planet's own internal processes or the slow drift of its journey through space. On a rogue planet, the absence of a star means there is no natural way to define a year. On Earth, our year is marked by the time it takes to orbit the sun, but rogue planets have no such anchor. Instead, their years are measured by their own internal clocks, perhaps by the decay of radioactive elements in their cores or the slow cooling of their surfaces. For a being living on such a world, time might feel fluid, unbound by the cycles of light and darkness that govern life on Earth. Imagine a world where the passage of time is felt rather than seen, where the only markers are the gradual changes in the planet's environment or the occasional flicker of a distant star in the night sky. This eternal night also shapes the planet's environment in profound ways. Without sunlight, the surface of a rogue planet remains perpetually cold, with temperatures often plunging to unimaginable lows. Yet, beneath the frozen surface, time might work differently. In the depths of a subsurface ocean, warmed by the planet's internal heat, life could exist in a timeless state, unaffected by the darkness above. Here, the concept of time might be tied to the slow churn of geothermal vents or the rhythmic tides of an underground sea, creating a unique rhythm of existence entirely separate from the world above. The lack of a star also raises intriguing questions about how life, if it exists, might adapt to such an environment. On Earth, life is deeply tied to the cycles of day and night, but on a rogue planet, organisms might evolve to thrive in a world without these cycles. They could develop entirely new ways of measuring time, perhaps relying on internal biological clocks or the subtle changes in their environment to guide their behavior. In this timeless realm, life might take on forms we can scarcely imagine, shaped by the endless night and the slow, unyielding passage of time. As we ponder the mysteries of time on rogue planets, we're reminded of how different these worlds are from our own. They challenge our understanding of time itself, offering a glimpse into a reality where the familiar rhythms of day and night are replaced by an eternal, unchanging darkness. And as we explore these ideas, we're drawn to the next chapter of their story, how rogue planets might connect to ancient myths and legends, inspiring tales of wandering worlds that have captivated human imagination for centuries. Now turning to the realm of mythology, let's explore how rogue planets have inspired tales and legends across cultures, weaving a tapestry of wonder and mystery. Throughout history, humans have looked to the skies and imagined celestial bodies as more than just distant worlds. They've seen them as symbols, omens, and even gods. Rogue planets, with their untethered journeys through the cosmos, have often been reflected in these ancient stories, embodying themes of isolation, freedom, and the unknown. In Greek mythology, for example, there are tales of wandering stars and celestial beings cast out from the heavens, forever drifting through the void. These stories echo the idea of rogue planets, worlds untethered from their stars, moving silently through the darkness. The Greeks saw these wandering lights as omens, often tied to the fates of heroes and kingdoms. Similarly, in Norse mythology, the concept of a lone traveler in the night sky is embodied by figures like the god Odin, who wandered the cosmos in search of wisdom, much like a rogue planet drifting through the galaxy. In other cultures, rogue planets might have been seen as messengers or harbingers of change. In Chinese folklore, celestial phenomena were often interpreted as signs from the heavens, with wandering stars sometimes representing the souls of the departed or the presence of divine forces. The idea of a world untethered from its star could have been seen as a symbol of transformation, a reminder of the impermanence of all things. Even in more modern interpretations, rogue planets continue to capture the imagination. In science fiction, they often serve as settings for stories of exploration and survival, where characters must confront the vast emptiness of space and the mysteries it holds. These tales reflect our own fascination with these wandering worlds, blending science and storytelling to explore what it means to exist in a universe filled with unknowns. As we connect these ancient myths to the science of rogue planets, we're reminded of how deeply intertwined human imagination is with the cosmos. These wandering worlds, once seen as omens or gods, now challenge us to rethink our place in the universe. And as we delve deeper into their mysteries, we're drawn to the next chapter of their story, how rogue planets have inspired creators in the realm of science fiction, becoming the backdrop for epic adventures and profound reflections on existence. Now turning to the realm of science fiction, let's explore how rogue planets have captured the imagination of writers and filmmakers, becoming the stage for some of the most thrilling and thought-provoking stories ever told. In science fiction, rogue planets are often portrayed as mysterious, uncharted worlds, drifting through the void of space, waiting to be discovered. These wandering worlds provide the perfect backdrop for tales of exploration, survival, and the search for meaning in an infinite universe. One of the most iconic depictions of rogue planets can be found in the classic science fiction novel Rogue Planet by Greg Bear. In this story, a rogue planet becomes the setting for a high-stakes mission where characters must navigate its alien landscapes and uncover its secrets. The planet's isolation and unpredictability create a sense of tension and wonder, making it a compelling setting for the narrative. Similarly, in the film Pitch Black, a rogue planet serves as the stage for a harrowing tale of survival, where the characters must confront not only the planet's harsh environment, but also the dangers lurking in its eternal night. Rogue planets also offer a unique opportunity to explore existential themes. In stories like The Wandering Earth by Liu Cixin, a rogue planet becomes a symbol of humanity's struggle against the vastness of the cosmos. The idea of a world untethered from its star forces characters and readers to grapple with questions of purpose, resilience, and the fragility of life. These narratives often reflect our own fears and hopes, using the rogue planet as a metaphor for the unknown challenges we face in our own lives. In addition to their role as settings, rogue planets often inspire creativity in world building. Writers and filmmakers imagine these worlds as places of extreme beauty and danger, with landscapes shaped by their unique conditions. From icy wastelands to volcanic plains, rogue planets offer endless possibilities for crafting visually stunning and emotionally resonant stories. Their lack of a star creates an atmosphere of perpetual twilight or darkness, adding an eerie, otherworldly quality to the narrative. As we reflect on the role of rogue planets in science fiction, we're reminded of their power to inspire both awe and introspection. These wandering worlds, once the stuff of myth and legend, now serve as a canvas for exploring the human condition and the mysteries of the universe. And as we look to the future, we can only imagine what new stories and adventures rogue planets will inspire as they continue to drift through the cosmos, waiting to be discovered. Now turning to the future, let's explore how advancements in technology and space exploration might bring us closer to unraveling the mysteries of rogue planets. While these wandering worlds have long eluded detailed study, the next generation of telescopes and missions promises to shed new light on their secrets. One of the most exciting tools in this quest is the James Webb Space Telescope, a marvel of modern astronomy. With its unparalleled ability to observe in infrared light, the James Webb Space Telescope can peer through the cosmic dust and darkness that often obscure rogue planets, revealing details about their atmospheres, temperatures, and even potential signs of life. But the James Webb Space Telescope is just the beginning. Future missions, like the Nancy Grace Roman Space Telescope, are being designed with the specific goal of detecting and studying rogue planets. Using a technique called gravitational microlensing, these telescopes can identify rogue planets as they pass in front of distant stars, bending and magnifying their light. This method allows astronomers to estimate the mass and size of these worlds, providing crucial insights into their composition and origins. Beyond telescopes, there's also the possibility of sending probes to study rogue planets up close. While the vast distances and lack of a guiding star make such missions incredibly challenging, advancements in propulsion technology, such as solar sails or nuclear-powered engines, could one day make this a reality. Imagine a spacecraft drifting through the void, approaching a rogue planet to analyze its surface, atmosphere, and internal heat sources. Such a mission could revolutionize our understanding of these enigmatic worlds and their potential to harbor life. As we look ahead, the study of rogue planets holds the promise of answering some of the most profound questions about our universe. Are these wandering worlds truly barren, or could they host hidden oceans beneath their icy surfaces? Could they even serve as waypoints for future interstellar travelers? The answers lie in the stars, waiting for us to reach out and uncover them. With each new discovery, we move one step closer to understanding the full story of these cosmic nomads and their place in the grand tapestry of the universe. Now turning to the vast expanse of our galaxy, let's explore how rogue planets are scattered throughout the Milky Way, weaving their silent paths among the stars. These wandering worlds, untethered to any star, are not rare anomalies, but rather a significant part of our cosmic neighborhood. In fact, some estimates suggest that rogue planets might even outnumber the stars in the Milky Way, making them a hidden yet integral part of the galaxy's fabric. Rogue planets are distributed unevenly across the galaxy, with some regions hosting more of these solitary travelers than others. They drift through the spiral arms, the central bulge, and even the sparse outer reaches of the Milky Way, their presence shaping the galaxy's dynamics in subtle but profound ways. While they don't emit light like stars, their gravitational influence can still be felt, subtly tugging on nearby stars and gas clouds as they pass by. This gravitational interaction, though faint, contributes to the intricate dance of matter and energy that defines the Milky Way's structure. One of the most fascinating aspects of rogue planets is their role in the galaxy's evolution. As they move through space, they can occasionally collide with other celestial bodies or be captured by the gravitational pull of a passing star. These rare events can lead to the formation of new planetary systems or even alter the orbits of existing ones. In this way, rogue planets act as cosmic wanderers, quietly influencing the galaxy's development over billions of years. Their distribution also offers clues about the history of the Milky Way. Some rogue planets may have been ejected from young star systems during the chaotic early stages of planetary formation, while others could have formed independently in the cold, dark regions of interstellar space. By studying their numbers and locations, astronomers can piece together a more complete picture of how our galaxy has grown and changed over time. As we gaze into the night sky, it's humbling to think that among the countless stars, there are even more rogue planets drifting unseen, their stories waiting to be uncovered. These cosmic nomads remind us that the Milky Way is not just a collection of stars and planets, but a dynamic, ever-changing tapestry, where even the loneliest worlds play a part in the grand story of the universe. Now turning to the mysterious and powerful forces that shape the cosmos, let's delve into the relationship between rogue planets and black holes. These cosmic giants, with their immense gravitational pull, create some of the most dramatic and awe-inspiring events in the universe. When a rogue planet drifts too close to a black hole, its fate becomes a story of cosmic extremes, where the forces of gravity and destruction collide. Imagine a rogue planet wandering silently through the void, suddenly caught in the gravitational grip of a black hole. As it spirals closer, the planet is stretched and compressed by the black hole's tidal forces, a process known as spaghettification. This intense stretching can tear the planet apart, reducing it to a stream of gas and dust that swirls into the black hole's event horizon, the point beyond which nothing can escape. It's a violent and mesmerizing end, a reminder of the raw power that black holes wield over their surroundings. But not all encounters end in destruction. Some rogue planets might be captured by a black hole's gravity, entering into a precarious orbit around it. These captured worlds would exist in a state of perpetual tension, balancing on the edge of annihilation. Over time, they might be drawn closer, eventually meeting the same fate as those torn apart by tidal forces. Yet, for a brief moment, they become part of the black hole's cosmic dance, adding to the complexity of its gravitational influence. Black holes can also act as cosmic slingshots, flinging rogue planets across the galaxy at incredible speeds. When a rogue planet passes near a black hole but avoids being captured or destroyed, the black hole's gravity can accelerate it to velocities that send it hurtling through space. These high-speed rogue planets become cosmic projectiles, traveling vast distances and potentially influencing other star systems, or even colliding with other celestial bodies. The relationship between rogue planets and black holes is a testament to the dynamic and often chaotic nature of the universe. These encounters, though rare, highlight the interconnectedness of all cosmic objects, from the smallest planets to the most massive black holes. They remind us that even in the vastness of space, no world is truly alone, and every object is part of a larger, ever-evolving story. As we ponder these dramatic interactions, we're reminded of the delicate balance that governs the cosmos. Rogue planets and black holes, though seemingly opposite in nature, are bound together by the same universal forces that shape the destiny of stars, galaxies, and even the universe itself. Their encounters are a vivid reminder of the beauty and brutality that coexist in the endless expanse of space. Now turning to the icy fringes of our solar system, let's explore the connection between rogue planets and the Oort cloud. This vast, distant region, filled with icy bodies and remnants from the early days of our solar system, might hold the key to understanding the origins of some of these wandering worlds. The Oort cloud, stretching far beyond the orbit of Neptune, is like a cosmic reservoir, preserving the building blocks of planets and comets in a frozen state. Some rogue planets may have begun their journey here, in the cold, dark reaches of the Oort cloud. Imagine a massive icy body drifting quietly in this distant region, nudged by the gravitational pull of a passing star or the subtle influence of nearby objects. Over time, this gentle push could send it hurtling out of the Oort cloud, setting it on a path toward interstellar space. Once free from the gravitational hold of the sun, this icy world becomes a rogue planet, destined to wander the galaxy alone. The journey from the Oort cloud to interstellar space is a slow and gradual one, taking millions or even billions of years. As the planet drifts away, it leaves behind the familiar boundaries of our solar system, venturing into the vast, uncharted expanse of the galaxy. Along the way, it might encounter other stars, black holes, or even other rogue planets, each interaction shaping its path and destiny. What makes these Oort cloud-borne rogue planets particularly fascinating is their icy composition. Unlike rocky or gas giant rogue planets, these worlds are likely covered in frozen water, methane, and other volatile compounds. In the cold depths of space, they remain frozen and dormant. But if they ever pass close to a star, their icy surfaces could briefly thaw, creating temporary atmospheres or even subsurface oceans. This raises intriguing questions about the potential for life on such worlds, even in the harshest conditions. The Oort cloud serves as a reminder of the dynamic and ever-changing nature of our solar system. It's a place where the past and future collide, where ancient icy bodies can become the rogue planets of tomorrow. As we ponder these distant wanderers, we're reminded of the countless mysteries that still lie hidden in the outer reaches of our cosmic neighborhood, waiting to be discovered. With the next phase of the journey in sight, we turn our attention to the companions these rogue planets might carry with them, moons that orbit these lonely worlds, adding another layer of intrigue to their story. Now turning to the companions of these wandering worlds, let's explore the possibility of rogue planets having moons or exomoons. These celestial companions add another layer of intrigue to the already mysterious nature of rogue planets. Imagine a rogue planet drifting silently through the void, accompanied by one or more moons orbiting it in the eternal darkness of interstellar space. These moons could range from small, rocky bodies to larger, icy worlds, each with its own unique characteristics. The presence of exomoons could significantly influence the environment of a rogue planet. For instance, the gravitational pull of a moon could create tidal forces, potentially heating the planet's interior and leading to geological activity. This internal heat might even create subsurface oceans, hidden beneath layers of ice, where conditions could be just right for life to exist. Picture a moonlit landscape on a rogue planet, where the faint glow of a distant moon illuminates icy plains and towering mountains, casting long shadows across a frozen world. It's a serene and otherworldly scene, one that sparks the imagination and invites us to ponder the possibilities. Exomoons could also play a role in stabilizing the rogue planet's rotation, preventing it from tumbling chaotically through space. This stability might create more predictable day-night cycles, even in the absence of a star, offering a semblance of rhythm to an otherwise timeless existence. Additionally, the interaction between a rogue planet and its moons could lead to fascinating phenomena, such as the exchange of material between the two bodies, potentially enriching the planet's surface with new compounds and minerals. As we consider these scenarios, we're reminded of the incredible diversity and complexity of the cosmos. Rogue planets, with their potential exomoons, challenge our understanding of planetary systems and the conditions necessary for life. They remind us that even in the coldest, darkest corners of the universe, there is beauty, mystery, and the potential for discovery. With the next phase of the journey in sight, we turn our attention to the dramatic encounters that rogue planets might face as they travel through the galaxy, including the possibility of cosmic collisions that could reshape their destinies. Now turning to the dramatic encounters that rogue planets might face, let's delve into the possibility of cosmic collisions. Picture a rogue planet drifting silently through the vast expanse of space, suddenly crossing paths with another celestial body. The collision could be a cataclysmic event, sending shock waves rippling through the fabric of the cosmos. These encounters, though rare, have the potential to reshape the destiny of these wandering worlds. When a rogue planet collides with another object, the impact could be transformative. Imagine the sheer force of two massive bodies crashing into each other, their surfaces fracturing and their cores merging. The collision might shatter the planet into fragments, scattering debris across interstellar space, or it could result in the formation of a new, larger body, forged from the remnants of the two. The aftermath of such an event could leave behind a trail of dust and gas, glowing faintly in the darkness, a testament to the violent encounter. These cosmic collisions could also have profound effects on the planet's environment. The heat generated by the impact might melt icy surfaces, creating temporary lakes or oceans that could persist for thousands of years. The collision could also trigger volcanic activity, releasing gases and minerals into the atmosphere, potentially altering the planet's climate. In some cases, the collision might even create new moons, as debris from the impact coalesces into smaller bodies orbiting the rogue planet. But collisions aren't always destructive. In some scenarios, they could lead to the creation of entirely new worlds. Imagine two rogue planets, each with its own unique composition, colliding and merging to form a single, larger planet. This new world might have a diverse landscape, with mountains, valleys, and plains formed by the collision. It could also have a rich mix of elements and compounds, providing the building blocks for complex chemistry and potentially life. As we ponder these possibilities, we're reminded of the dynamic and ever-changing nature of the universe. Rogue planets, though often seen as solitary wanderers, are not immune to the forces that shape the cosmos. Their collisions with other celestial bodies are a reminder of the constant interplay of creation and destruction that defines the universe. With the next phase of the journey in sight, we turn our attention to the search for extraterrestrial intelligence and how rogue planets might hold clues to this enduring mystery. Now turning to the search for extraterrestrial intelligence, let's explore how rogue planets might play a surprising role in this cosmic quest. These wandering worlds, untethered to any star, could be ideal hiding places for advanced civilizations. Imagine a society that has evolved beyond the need for starlight, harnessing the internal heat of a rogue planet to sustain itself. Such a civilization might thrive in the darkness, using the planet's resources to build vast underground cities or floating habitats in its atmosphere. Rogue planets offer a unique advantage for civilizations seeking isolation. Without a star to draw attention, these worlds could remain hidden from prying eyes, making them perfect sanctuaries for societies that value privacy or security. The lack of a star also means there's no predictable orbit to track, making it harder for outsiders to locate them. For a civilization that has mastered the art of survival in extreme environments, a rogue planet could be the ultimate refuge. But isolation isn't the only reason rogue planets might attract intelligent life. These worlds could also be rich in resources, from subsurface oceans to vast reserves of minerals and gases. A technologically advanced civilization might see a rogue planet as a treasure trove, offering everything needed to sustain a thriving society. The planet's internal heat could provide energy for countless generations, while its icy surface or dense atmosphere might shield inhabitants from cosmic radiation. The search for extraterrestrial intelligence often focuses on planets within the habitable zones of stars, where conditions are just right for liquid water. But rogue planets challenge this assumption, suggesting that life, and even intelligence, might exist in the most unexpected places. By expanding our search to include these wandering worlds, we open up new possibilities for discovering civilizations that have adapted to life in the void. As we consider the potential of rogue planets in the search for extraterrestrial intelligence, we're reminded of the boundless creativity of the universe. These worlds, once thought to be barren and lifeless, might hold the key to one of humanity's greatest questions. Are we alone in the cosmos? With the next phase of the journey in sight, we turn our attention to the connection between rogue planets and the Fermi paradox, exploring how these enigmatic worlds might hold clues to this enduring mystery. Now turning to the multiverse, let's explore how rogue planets might fit into this mind-bending concept. The multiverse theory suggests that our universe is just one of many, each with its own unique laws of physics and possibilities. In this vast cosmic tapestry, rogue planets could serve as more than just wanderers. They might act as bridges or gateways between these parallel realities. Picture a rogue planet drifting through the void, its surface shimmering with strange energies as it moves between dimensions. Could these worlds be cosmic waypoints, connecting universes in ways we've yet to understand? The idea of rogue planets as interdimensional travelers adds a layer of mystery to their already enigmatic nature. In a multiverse, where countless realities exist side by side, these planets might carry traces of other worlds, strange materials, exotic life forms, or even remnants of civilizations from alternate dimensions. Imagine a rogue planet passing through a wormhole, emerging in a new universe with a completely different set of physical laws. Such a journey could transform the planet, reshaping its environment and perhaps even its inhabitants. But how might rogue planets interact with the multiverse? One possibility is that their lack of a star makes them uniquely suited to navigate the boundaries between universes. Without the gravitational pull of a star, these planets could move freely through cosmic gateways, slipping between dimensions with ease. Their isolation might also make them ideal candidates for harboring life that has evolved to thrive in multiple realities, adapting to the ever-changing conditions of the multiverse. As we ponder the role of rogue planets in the multiverse, we're reminded of the infinite possibilities that lie beyond our understanding. These wandering worlds, once thought to be solitary and unchanging, might hold the key to unlocking the secrets of parallel realities. With the next phase of the journey in sight, we turn our attention to the end of the universe, exploring how rogue planets might outlast stars and galaxies, enduring in a cosmos that is both vast and mysterious. Now turning to the end of the universe, let's imagine a future where stars have burned out, galaxies have faded, and the cosmos is cloaked in eternal darkness. In this distant era, rogue planets might be the last survivors, drifting through a cold and silent void. These wandering worlds, untethered from stars and unbound by time, could endure long after everything else has vanished. Picture a rogue planet, its surface frozen and lifeless, yet still moving through the emptiness of space. It's a haunting image, one that reminds us of the vastness and inevitability of cosmic time. What makes rogue planets so resilient? Unlike planets bound to stars, they don't rely on starlight for warmth or energy. Instead, their internal heat, generated by radioactive decay or residual warmth from their formation, could keep them active for billions of years. Even as the universe cools and expands, these planets might continue their solitary journeys, their surfaces untouched by the passage of time. Imagine a rogue planet, its icy crust hiding a subsurface ocean, still liquid and perhaps teeming with life, long after the stars have gone dark. But what happens when even the rogue planets reach the end of their existence? In a universe where entropy reigns supreme, even these hardy survivors will eventually succumb to the cold. Their internal heat will fade, their oceans will freeze, and their surfaces will become barren and lifeless. Yet, even in this final state, rogue planets will remain as silent witnesses to the cosmos, their lonely orbits a testament to the enduring nature of the universe itself. As we contemplate the fate of rogue planets at the end of the universe, we're reminded of the fragility and resilience of existence. These wandering worlds, once thought to be insignificant, might outlast everything else, carrying the echoes of a universe that once was. With the next phase of the journey in sight, we turn our attention to the role of rogue planets in human imagination, exploring how these mysterious worlds inspire artists, writers, and dreamers across the ages. Now turning to the role of rogue planets in human imagination, let's explore how these mysterious worlds have captivated the minds of artists, writers, and scientists alike. Rogue planets, with their solitary journeys through the vastness of space, have become powerful symbols in our collective consciousness. They represent isolation, drifting alone in the infinite void, yet they also embody freedom, untethered from the gravitational pull of stars and the constraints of solar systems. For many, they are the ultimate metaphor for exploration, a reminder of the boundless possibilities that lie beyond the familiar. In literature and art, rogue planets often serve as backdrops for stories of adventure and discovery. Writers imagine these wandering worlds as settings for epic tales, where characters confront the unknown and grapple with the mysteries of existence. Artists, too, are drawn to their haunting beauty, creating vivid depictions of icy landscapes, bathed in eternal twilight, or gas giants adrift in the darkness of interstellar space. These creative works not only inspire awe, but also invite us to reflect on our place in the universe and the enduring human desire to explore the unknown. For scientists, rogue planets are more than just objects of curiosity. They are windows into the fundamental processes that shape the cosmos. Their existence challenges our understanding of planetary formation and evolution, prompting new questions about the origins of life and the potential for habitable environments in the most unlikely places. By studying these wandering worlds, researchers hope to uncover clues about the early universe and the forces that govern it. In this way, rogue planets not only fuel our imagination, but also drive the pursuit of knowledge, bridging the gap between art and science. As we reflect on the symbolic significance of rogue planets, we are reminded of their dual nature, both as solitary wanderers and as sources of inspiration. They remind us of the beauty and mystery of the cosmos, urging us to look beyond the familiar and embrace the unknown. With the next phase of the journey in sight, we turn our attention to the concept of rogue planets and the Goldilocks zone, exploring how these worlds might create their own conditions for life, even in the absence of a star. Now turning to the concept of rogue planets and the Goldilocks zone, let's explore how these wandering worlds might create their own unique conditions for life. The Goldilocks zone, often referred to as the habitable zone, is typically defined as the region around a star where temperatures are just right for liquid water to exist, a key ingredient for life as we know it. But what if a planet doesn't orbit a star at all? Could a rogue planet, drifting alone in the cold darkness of space, still harbor the conditions necessary for life? The answer lies in the planet's internal heat. While rogue planets lack the warmth of a nearby star, some of them generate their own heat through processes like radioactive decay in their cores or the gravitational energy from their formation. This internal heat can create pockets of warmth beneath the surface, potentially allowing for liquid water to exist in subsurface oceans. Imagine a world where the surface is frozen and barren, but deep below, hidden beneath layers of ice, lies a vast, warm ocean teeming with the possibility of life. These subsurface oceans could be shielded from the harsh conditions of space, providing a stable environment for life to thrive. Scientists have speculated that such environments might exist on rogue planets, particularly those with thick icy shells and active geological processes. For example, a rogue planet with a molten core could maintain hydrothermal vents on its ocean floor, similar to those found on Earth's deep seafloor. These vents are known to support unique ecosystems, even in the absence of sunlight, relying instead on chemical energy. This raises the tantalizing possibility that rogue planets, despite their isolation, could host life forms adapted to these extreme conditions. The idea of a rogue planet creating its own Goldilocks zone challenges our traditional understanding of habitability. It suggests that life might not be confined to planets orbiting stars, but could exist in the most unexpected places, sustained by the planet's internal heat rather than starlight. This opens up new avenues for exploration and discovery as astronomers consider the potential for life on these wandering worlds. As we ponder the possibilities, we are reminded once again of the boundless creativity of the universe. Rogue planets, with their ability to carve out habitable niches in the void, remind us that life may find a way even in the most unlikely of places. With this thought in mind, we now turn our gaze to the cosmic nomads of the galaxy, exploring the poetic journeys of these wandering worlds and the mysteries they carry through the vast expanse of space. Now turning to the poetic wanderers of the cosmos, let us envision rogue planets as cosmic nomads, drifting endlessly through the vast expanse of the galaxy. These solitary travelers, untethered from the warmth of any star, embark on journeys that span eons, their paths shaped by the invisible forces of gravity and the whims of the universe. Picture them as silent voyagers, gliding through the cold, dark void, their surfaces cloaked in eternal night, yet carrying within them the potential for untold stories and hidden wonders. Each rogue planet is a world unto itself, a self-contained realm that moves through space with a quiet determination. Some may be icy wanderers, their surfaces frozen and barren, while others could be rocky travelers, their interiors pulsing with the heat of radioactive decay. Regardless of their form, these cosmic nomads share a common destiny: to roam the galaxy, untethered and free, their journeys marked by solitude and mystery. Imagine the life of a rogue planet, born in the chaos of a young star system, only to be cast adrift by the gravitational tug of a passing star or the violent upheaval of its own formation. Once set on its path, it becomes a wanderer, a celestial drifter that may never again feel the warmth of a star's light. Yet even in its isolation, a rogue planet carries with it the potential for life, its internal heat creating pockets of warmth where liquid water might flow and where life in some form could take hold. As these cosmic nomads travel through the galaxy, they pass by stars, nebulae, and other celestial wonders. Their journey is a testament to the vastness and diversity of the universe. Some may be captured by the gravity of a passing star, finding a new home in a distant system, while others continue their solitary voyages, destined to wander forever. Their paths are unpredictable, their destinations unknown, and yet they move forward with a quiet grace, embodying the spirit of exploration and discovery. In their endless wanderings, rogue planets remind us of the boundless possibilities of the cosmos. They challenge our understanding of habitability and life, showing us that even in the coldest, darkest corners of space, there may be worlds waiting to be discovered. As we contemplate their journeys, we are drawn into the mystery and beauty of the universe, inspired by the resilience and adaptability of these cosmic nomads. With this sense of wonder, we now turn our attention to the next chapter of their story, exploring how rogue planets might influence the formation of stars and planetary systems, and the role they play in the grand cosmic dance of creation and destruction. Now turning to the intriguing intersection of rogue planets and the search for extraterrestrial intelligence, let us explore how these wandering worlds might influence the Drake equation. This famous formula, crafted by astronomer Frank Drake, attempts to estimate the number of intelligent civilizations that might exist in our galaxy. It considers factors like the rate of star formation, the likelihood of planets orbiting those stars, and the probability of life emerging on those planets. But where do rogue planets fit into this cosmic calculation? Rogue planets, untethered from any star, add a fascinating layer of complexity to the Drake equation. Traditionally, the equation assumes that life requires a stable environment, often tied to a star's warmth and light. However, rogue planets challenge this assumption. Some of these wandering worlds might harbor subsurface oceans, kept liquid by internal heat from radioactive decay or tidal forces. These hidden oceans could provide the conditions necessary for life, even in the absence of starlight. This means that rogue planets could significantly increase the number of potentially habitable worlds in the galaxy, expanding the scope of the Drake equation. Moreover, rogue planets might serve as refuges for life in extreme environments. Imagine a civilization that evolves on a rogue planet, adapting to its unique challenges and thriving in the darkness. Such a scenario would not only broaden our understanding of habitability, but also suggests that intelligent life could exist in places we've never thought to look. This possibility underscores the importance of including rogue planets in our search for extraterrestrial intelligence, as they could hold clues to life's resilience and adaptability. The presence of rogue planets also raises questions about the longevity of civilizations. If a rogue planet's internal heat can sustain life for billions of years, it might outlast stars and their planetary systems. This could make rogue planets ideal locations for advanced civilizations seeking stability in an ever-changing universe. Their isolation might even protect them from cosmic threats like supernova or gamma-ray bursts, offering a safe haven for life to flourish over unimaginable timescales. As we consider the role of rogue planets in the Drake equation, we are reminded of the vastness and mystery of the cosmos. These wandering worlds challenge our assumptions and inspire us to think beyond the familiar. They remind us that life, in all its forms, might exist in the most unexpected places, waiting to be discovered. With this in mind, we turn our gaze to the next chapter of their story, exploring how rogue planets might connect to the Fermi paradox and the enduring question of why we have yet to encounter extraterrestrial life. Now turning to the enigmatic connection between rogue planets and the Fermi paradox, let us delve into one of the most profound questions in science. If the universe is so vast and filled with potential for life, why haven't we encountered any signs of extraterrestrial intelligence? This paradox, named after physicist Enrico Fermi, challenges our understanding of the cosmos and our place within it. Rogue planets, with their unique characteristics, might offer intriguing insights into this enduring mystery. One possibility is that rogue planets could serve as hidden sanctuaries for advanced civilizations. Unlike planets orbiting stars, these wandering worlds are not bound to a single source of light or heat. This independence might allow civilizations on rogue planets to remain undetected, avoiding the risks of cosmic events like supernova or gamma-ray bursts that could threaten life on star-bound worlds. Their isolation could make them ideal locations for civilizations that prefer to remain hidden, either by choice or necessity. Another angle to consider is the sheer difficulty of detecting life on rogue planets. Without a star to illuminate them, these worlds are incredibly challenging to observe. Traditional methods of searching for extraterrestrial life, such as looking for biosignatures in a planet's atmosphere, are nearly impossible to apply to rogue planets. This invisibility might explain why we haven't found evidence of life on these worlds, even if they are teeming with it. The Fermi paradox, in this context, might not be a paradox at all, but rather a reflection of our technological limitations. Rogue planets also raise questions about the nature of life itself. If life can exist in the extreme environments of these wandering worlds, it might be far more adaptable and resilient than we currently imagine. This adaptability could mean that life on rogue planets evolves in ways that are entirely different from life on Earth, making it even harder for us to recognize or communicate with such civilizations. The Fermi paradox, then, might be a reminder of how little we truly understand about the potential diversity of life in the universe. As we ponder the role of rogue planets in the Fermi paradox, we are reminded of the vastness and mystery of the cosmos. These wandering worlds challenge our assumptions and inspire us to think beyond the familiar. They remind us that life, in all its forms, might exist in the most unexpected places, waiting to be discovered. With this in mind, we turn our gaze to the next chapter of their story, exploring how rogue planets might be part of the cosmic web, the intricate network of galaxies, dark matter, and cosmic filaments that shape the universe. Now turning to the cosmic web, let us explore how rogue planets might fit into this vast, interconnected structure that defines the universe. The cosmic web is a sprawling network of galaxies, dark matter, and cosmic filaments, forming the backbone of the cosmos. It's a tapestry of light and shadow, where galaxies cluster along glowing threads, separated by vast voids of emptiness. Within this grand design, rogue planets may play a subtle yet fascinating role. Imagine the cosmic web as a colossal spider's web, stretching across the universe. Galaxies are the shimmering dewdrops, clinging to its strands, while dark matter forms the invisible threads that hold it all together. Rogue planets, drifting freely through space, could be likened to tiny, unseen travelers moving along these filaments. Though they don't emit light or gather in clusters like stars and galaxies, their presence might still influence the delicate balance of the cosmic web. One way rogue planets could contribute to this structure is through their gravitational pull. Even though they are small compared to galaxies, their combined mass could subtly affect the distribution of dark matter and the flow of cosmic filaments. Over billions of years, these wandering worlds might help shape the web's intricate patterns, adding another layer of complexity to the universe's architecture. Another intriguing possibility is that rogue planets could act as cosmic waypoints, marking the paths along which galaxies and star systems form. As they drift through the voids and filaments of the cosmic web, they might occasionally pass near regions of dense gas and dust, triggering the collapse of these materials into new stars and planets. In this way, rogue planets could play a quiet but vital role in the ongoing story of cosmic creation. The cosmic web also raises questions about the origins of rogue planets. Could some of these wandering worlds have been born within the dense filaments of the web, only to be flung into the void by gravitational interactions? Or might they have formed in the voids themselves, where the conditions are vastly different from those in star systems? These questions remind us that the cosmic web is not just a static structure, but a dynamic, ever-changing network, with rogue planets as its silent wanderers. As we contemplate the place of rogue planets in the cosmic web, we are reminded of the interconnectedness of all things in the universe. These drifting worlds, though seemingly isolated, are part of a larger tapestry, woven together by gravity, dark matter, and the forces of creation. They remind us that even in the vast emptiness of space, nothing exists in true isolation. With this thought, we prepare to explore the next chapter of their story, where we'll consider how rogue planets might survive the end of the universe itself, outlasting stars and galaxies in the cold, dark expanse of eternity. Now turning to the infinite cosmos, let us reflect on the boundless expanse of the universe and the role rogue planets play in reminding us of its vastness and mystery. These wandering worlds, untethered to any star, drift through the endless void, embodying the solitude and grandeur of the cosmos. As we gaze into the night sky, It's easy to feel small in the face of such immensity, yet there is a strange comfort in knowing that even in the vastness, there are stories waiting to be discovered. Rogue planets, with their silent journeys through the darkness, serve as a reminder of the infinite possibilities that exist beyond our understanding. They are like cosmic whispers, hinting at the secrets hidden in the farthest reaches of space. Each one carries with it the potential for discovery, whether it's the possibility of life in the most unexpected places or the chance to unravel the mysteries of their origins. In their solitude, they invite us to ponder the nature of existence itself. Imagine the journey of a rogue planet, drifting for billions of years through the cold, empty stretches of space. It is a journey without end, a testament to the timeless nature of the universe. These worlds remind us that time, as we know it, is but a fleeting moment in the grand tapestry of the cosmos. They challenge us to think beyond the confines of our own lives and consider the infinite cycles of creation and destruction that shape the universe. As we contemplate the infinite cosmos, let us also find peace in its vastness. The universe is a place of endless wonder, where every star, every planet, and every rogue world has a story to tell. These stories, though often hidden from our view, are part of a larger narrative that connects us all. In the quiet moments before sleep, let your mind wander among the stars, carried by the gentle currents of the cosmos. Picture the rogue planets. Their silent journeys a reminder of the beauty and mystery that lies beyond our reach. And as you drift into sleep, let the infinite cosmos cradle your thoughts. Imagine the endless expanse of space, filled with worlds both known and unknown, each one a testament to the boundless creativity of the universe. In this moment, you are part of something greater, a tiny yet significant thread in the fabric of existence. Let the mystery of rogue planets guide you into a peaceful slumber, where dreams of the cosmos await. Now turning to the conclusion of our cosmic journey, let us reflect on the mystery and significance of rogue planets. These wandering worlds, untethered to any star, drift silently through the vast expanse of space, embodying the solitude and grandeur of the universe. They remind us of the infinite possibilities that exist beyond our understanding, challenging us to think beyond the confines of our own lives and consider the timeless cycles of creation and destruction that shape the cosmos. Rogue planets, with their silent journeys through the darkness, serve as a testament to the boundless creativity of the universe. Each one carries with it the potential for discovery, whether it's the possibility of life in the most unexpected places or the chance to unravel the mysteries of their origins. In their solitude, they invite us to ponder the nature of existence itself, reminding us that we are part of something greater, a tiny yet significant thread in the fabric of existence. As we conclude our exploration of these enigmatic worlds, let us find peace in the vastness of the cosmos. The universe is a place of endless wonder, where every star, every planet, and every rogue world has a story to tell. These stories, though often hidden from our view, are part of a larger narrative that connects us all. In the quiet moments before sleep, let your mind wander among the stars, carried by the gentle currents of the cosmos. Picture the rogue planets. Their silent journeys a reminder of the beauty and mystery that lies beyond our reach. and as you drift into sleep, let the infinite cosmos cradle your thoughts. Imagine the endless expanse of space, filled with worlds both known and unknown, each one a testament to the boundless creativity of the universe. In this moment, you are part of something greater, a tiny yet significant thread in the fabric of existence. Let the mystery of rogue planets guide you into a peaceful slumber, where dreams of the cosmos await. Thank you for joining us on this journey through the mysteries of rogue planets. If you enjoyed this cosmic sleep story, please share your thoughts in the comments below, and don't forget to subscribe for more explorations of the universe's wonders. Sweet dreams, and may your nights be filled with the endless possibilities of the cosmos.
you.